Okay, in this question, the hydrated compound here has been, we're trying to find its formula by finding this value of x. Okay, so remember, we don't know the molecular weight of the compound at all at the moment. Okay, so we can't use that in finding anything out to begin with. What's happened is the compound has been dissolved in water and barium chloride has been added in order to precipitate out all of the sulfate ions, like so. And so what we're finding first of all is the amount in moles of barium sulfate. And so to find that, we find the number of moles being equal to the mass divided by the molar mass from the periodic table of barium sulfate. And in that case we find we get a value 5.01 times 10 to the power of negative 3 moles. That's straightforward enough. The next part though requires a bit of thought. The idea here is that all of the sulfate here, all of this sulfate has been converted to the sulfate here, the barium sulfate. It was precipitated, the sulfate in the compound was precipitated out as this. So the value for the number of moles of sulfate here is the same as the one we've just found out. Next, if we look at our formula for the barium sulfate, which I can't see here because of this funny symbol, if we look at our formula, we can see that for each iron particle in the compound, there are 2 sulfate particles. So if we're trying to find the number of moles of iron, it's going to be 1/2 of what we have of sulfate. And so that gives me 2.50 times 10 to the power of negative 3 moles of iron in the compound. We're now asked to find the mass of each of the following present in the sample. Iron is here. Of iron, if we find the molar mass of iron from our periodic table, 55.85, we multiply by the number of moles of it we just calculated, and we end up with 0.140 grams of iron. The ammonium, that's the NH4. NH4 plus has the molar mass of 18.05. We multiply that by the number of moles, it gives us 0.0904. Why do we have that many moles? Well, because the number of moles of ammonium is the same as the number of moles of sulfate. There's a 2 here and a 2 here. And the number of moles of sulfate, well, sulfate has the mass 96.06. Multiply that by the number of moles we calculated earlier, and we get a mass of 0.481. Now, it's worth pointing out here, I know some of you will have multiplied these values by 2 because of the 2 here. That's incorrect. We've already taken into account that when we were finding out the number of moles of each. Okay, moving on. It asks us now to use our answers from D to determine the amount in moles of water present in the compound. Well, we're just going to add up what we found already. That gives us mass of 0.711 grams. So our mass of water is equal to 0.982. Subtract that, which gives us 0.271 grams. So if we work out the number of moles, that's 0.271 divided by the molar mass of water, which ends up giving me 1.50 times 10 to the negative 2 moles. Okay, now it wants us to determine the amount in moles of this. Well, we know, we've just worked out up here that the mass of that substance is 0.711 grams. If we work out the molar mass of that, we get 284.07. So the number of moles of that is 2.50 multiplied by 10 to the negative 3. And so now we can work out our ratio of the compound gives me 2.50 times 10 to the negative 3. So 1.50 times 10 to the power of negative 2. I divide by the smallest, which is this value. I end up with a value of x being 6. There you go.